All right. So P-7 has us solving inequalities algebraically and graphically. That was why I asked you to have that graphing calculator handy. And the things you were pre-rating yourself on in the yellow lesson objectives would be solving absolute value inequalities. That is a skill that you had in Algebra 2. In fact, we just covered it at the end of Chapter 1. So it's been a while, but you had that skill. Solving quadratic inequalities. They maybe had a little bit of time last year to cover that. And then we're going to approximate solutions to inequalities and write and solve problems involving a projectile motion. We won't get to that until tomorrow. So we're going to go, I think, through everything quadratic today, and then we'll stop and say, hey, let's leave the rest of this for finishing up for tomorrow. On a graph of y equals x squared minus 4, what are the values of x where y equals x squared minus 4 lies below the x-axis? So the first thing I'm thinking is, there's my parent function, a good old quadratic family. And just in case we've forgotten, we went ahead and put in numbers like -3 to 3 and said, okay, if we square them, that's going to be 9, 4, 1, 0, 1, 4, 9. But this one has the -4 tacked in the back. And that's because when we think about our good old h and k, that -4 is a k. So we would take all of these points and we would move them 4 units down. So instead of the vertex being at 0, 0, it's going to be down here at 1, 2, 3, 4. And then we can kind of pretend that's our new 0, 0 and go to 1, 1, 2, 4, and 3, 9, which I hope is around there. These are really, really light up here today. So that's the graph of y equals x squared minus 4. Like so. So this is asking us, where would it lie below the x-axis? And here's where I'd like you to take that second color and realize it's right here. So if that's the question that we're supposed to answer, we would say, well, when x is between, it's like -2 and 2 up there. And that's what we do when we're talking about inequalities. This one's kind of leading us there to the inequality piece. So x would be between -2 and 2. And then I ask myself, well, should I include -2 and 2? Well, no, it said below the x-axis. It didn't say equal to the x-axis. And then, of course, even though this is our thinking, we stop and say, oh, this is pre-calculus, though. Going to need that in interval notation. So this one ends up being an and sandwich. This is a compound inequality called an and statement. And what and does is it sandwiches our variable between those two endpoints that we want to look at. So this is what we're talking about today, finding these solutions. So we're going to solve some absolute value inequalities just like you did in Algebra 2, and then we'll go from there. So solving absolute value inequalities, it says let u be an algebraic expression in x, let a be a real number where a is greater than or equal to 0, if the absolute value of u is less than a, then u is in the interval from -a to a. In that last graph, we just saw all the stuff that was below the x-axis was what we needed, and that was an and statement. So from -a to a, our interval will tell us u, our solution, is sandwiched between -a and a, if it says greater than. Well, then we're choosing the other pieces. This green was for less than. these two pieces would be for greater than, because the x-axis was the cutoff. Now the x-axis isn't always going to be the cutoff. There are times when they're going to explain to us, hey, we've got a number over here that we want you to use. But we need to remember that absolute value with less than is going to be an and statement, an and sandwich. And then when we have greater than with absolute value, that's going to be an or statement, an either or statement. So here with this absolute value graph, which I hope we remembered as a V, there it is. The solution to the absolute value of u is less than a, and I'm going to color code it, is here. Now I know that because this is a, and it said the absolute value has to be less than a, so it's got to be under there. And then it says the solution to the absolute value of u is greater than a, so I'll color code that one, is represented here and here. So notice how my green arrows are going to the extremes on the number line. We're going to have all the super negatives and all the super positives out there that we're going to be dealing with. And it really comes down to understanding and is what we use when we have absolute value and less than. And or is what we use when we need absolute value and greater than working together. But the visual is a new twist for us, you know. In Algebra 2, you didn't see them. You didn't know how to graph them yet. And at some point, they said, all right, let's just learn how to solve these. So we are going to be using interval notation. How do we write this or business in interval notation? And that's going to be with the union of two sets. So the union of two sets, A and B, and this might be totally new to some of you. Did any of you in here take prob and stats? Most of the time when you're accelerated, okay, so we've got a couple of people that have taken prob and stats. Most of the time when you're accelerated, that's a class you skip, is prob and stats. So the union of two sets A and B is just, it looks like a big U. That says either or. That's what the union symbol is for. So like it says, it's the set of all objects that belong to A or B or both. So we're starting to get into more math symbols. If you go on to college to study math, you actually have to take a course called logic. And logic is about learning all of those symbols and all the things that they stand for in math. So this is what we use when we need to do or. All right. We're going to solve an absolute value inequality. So I look at this one and I see the absolute value of x minus 4 is less than 8. So I'm thinking to myself, less than. The distance from 0 is less than 8. And if I'm standing at my 5th grade teacher's number line and I'm at 0, I'm thinking, well, that's all the stuff I can reach out here to -8 and all the stuff I can reach here to +8, and I'll pull all that in. And that's an and sandwich. So my x minus 4. Oh, I keep wanting to write the absolute value symbols. I'm trying to drop those. Because I'm thinking about a story that we tell the Algebra 2 students to get them to remember how to deal with absolute value. And it deals with the fact that these are prison bars. And if you're a prisoner that seriously wants to escape, you'll always have 2 escape routes. So to get out of prison, you have one in the negative direction and one in the positive direction, and that's how you drop those prison bars. That's how you get outside the prison bars. And then this is a 3-parter where we go ahead and add 4 to all 3 pieces. And we get that solution. Now, like it says, we're going to write these in interval notation, so I remember and. Okay, and is like walking along the number line. So I need -4, but I can't include it. And I'm going to keep going till I get to 12, but I can't include that. But now what I want to do is I want to see the visual of it. So I want to see the absolute value of x minus 4 and where that cutoff is with 8. So I go to my graphing calculator. And I go into y equals. Oops, I must have accidentally hit second there. There we are. And I remember absolute value, not something we use a whole lot, but it's under math. Numbers, 1. And this one for the smartboard is a newer one, so it actually gives me the bars for absolute value. If you have an older one, like this one here, this is the one I use for the TV, that's older, it still uses parentheses. But either way, it's going to be absolute value. And then we want x minus 4. Pop it out, and we want to see when is that 8. Now, I think about what that's going to look like. X minus 4, where the minus 4 is inside those absolute value bars, that would be x minus h. So that's actually going to go 4 units to the right for the vertex. And I want to see where it hits 8. So I should be okay with zoom 6. Zoom 6 does that negative 10 to 10 window. And I see, oh, well, this one's good. That one I couldn't quite fit on there. And I remember, well, that's because it was 12. You know, I just solved it algebraically. So I'm going to need my x's to go a little bit higher. And I can change that to 15. And then hit graph. Now I can see. Yeah, should be from here to here. Now we already solved it algebraically. But if we wanted to know exactly where those two spots were, we could do second trace and call up my pet Blinky. Blinky is my pet cursor. Hypoallergenic. Nobody will ever get a rash because of Blinky. Blinky is our calculator's means of giving us a cursor to find things. So number 5 there is intersect. And Blinky's a little lost right now. You know, there's a question mark down here. Is this the first curve? I'm going to move Blinky up here a ways so that Blinky knows I really want this one first. And then I'll hit enter. And now Blinky went to the red one, which is what I want. I want that horizontal line intersection. And then just Blinky is always playful. Always wants me to take a guess. No, Blinky, I'm using you because I don't want to take a guess. So I hit enter. And Blinky tells me this is negative 4. X equals negative 4. That's what I had. And if I want to make sure on the other one, I do the same thing. Second trace. Number 5. But this is where I wish Blinky had elevator music playing in the background, because sometimes it takes Blinky a while to get where he needs to go. Come on, Blinkster. There we go, up there. Enter, enter, enter. No shocker that it's 12. You know, we knew that by solving it algebraically. But what we can see in this graph is if we are talking about that less than piece, those are the x's that we need to describe, because the x's are the solutions. And that's what we did. We said, hey, between here and here with the interval notation. So it's always good if you have time, and that's, you know, with pre-calc tests, it's pretty rare that we have lots of time to double check, but if you have time, always a good idea, plop it in the graphing calculator, take a peek, and then you probably want to make a little bit sketch there on your paper, and then color code this. Let's see, I wrote all this in red. So I'll do that. So that you remember, for the visual, if we're talking about less than, well, it's got to be less than 8. Where is 8? Where's that cutoff? Or y equals 8? And what x values are we talking about here for the solutions? So this is Algebra 2 on steroids. Because like I said, when you were in Algebra 2, we just said, hey, make the jailbreak. You know, that's how you do these problems. But now we're putting that visual together. So we can see, this is what's going on with the graph. And use that to verify what we know. Did you remember that absolute value graphs were V's? Okay, some people are like, yeah, I got that. Now that said, I'm probably not going to use the graphing calculator a whole lot today. I mean, I wanted to show you how those two things are going to be connected. but I'll uncover the boxes so that you can get a look at it as you go through that. So I'm looking at this one. And this one says the absolute value of 3x minus 2 is greater than or equal to 5. And in my visual, I'm seeing my absolute value graph, but I'm looking at the stuff that's going to the extremes up above. So I remember that that's going to be 3x minus 2 is less than or equal to negative 5, or 3x minus 2 is greater than or equal to positive 5. Again, kind of the jailbreak thing, you know, to get out of the absolute value bars, you have to have two setups. And then we just solve these, same steps, but solve them separately. So adding 2 to both sides. Dividing by 3. Adding 2 to both sides. And dividing by 3. And with inequalities, that little 2-letter word of or was a really huge deal. But we want to think of this visually so that we can think of that number line for interval notation. And I realized, well, x is less than or equal to negative 1. That's going to go to infinity, negative infinity. And then when I hit negative 1 on the number line, I have to stop, and it's included. So I have to use my brackets. And then I remember my new notation. I'm not supposed to write or here. This is all math notation. This is going to be my big U. Union says or. I want to include the 7/3, and then on to infinity forever. So with this one, let's make the sketch in your notes. But when we color code this one, we're talking here and here, and including those 2 points because it had the equals bar. So everybody can see here. I always feel like I'm in the way now that the desks have to be up so far. Now, if you're looking at this one thinking, oh gosh, I don't remember what we were supposed to do back in Algebra 2 to feel our way through the, a absolute value of x minus h plus k. Well, what we did was we would factor out that 3. Because remember, we know that we can factor out absolute values. And then we would get our graph from there. Or we could just put it in the graphing calculator and take a peek. But we shouldn't be shocked by the results. Our algebra is what tells us we're doing things right. The graph is just to verify. That's all it is. Feeling okay about this? All right, so let's keep going. Because these were all absolute value. Now we want to talk about quadratic inequalities. Like I said, this one, it might be brand new. It's one of those things we tend to throw in if we have time at the Algebra 2 level. And with last spring, I'm not sure you saw all this yet. So we will need to be able to solve quadratics. Well, we're experts at that. That's fantastic. What are some of the methods that we use to solve quadratics? What's our go-to, our first one always? What do we use to try to solve a quadratic? Hoping that it's the easiest way. I see it was a long Monday for you guys too. We always try to factor. Always. We're good at it. Had a whole class, it seems like. Exponential is most of the time that you're in exponential, you spend factoring. That's what you do. So we try factoring. If that's not working, well, sometimes the problem is set up so we can do the extracting of square roots. Sometimes. Not very often, but sometimes. Because usually those steps come from completing the square. And then we're using the process of extracting square roots while we're completing the square. And then only if the problem specifically says use the quadratic formula do we do that. That is a backup. Because remember, You have not seen the quadratic formula derived yet. That takes calculus. Completing the square, we know all the steps to that, and we know why it works. But quadratic formula, got to wait until calculus. However, as I mentioned before, when you take the MCAs and the ACTs, if you've forgotten these first three things, remembering the little x equals negative b plus or minus the square root of b squared minus 4ac all over 2a will get you the right answer. So it's a backup plan, and it's a good one. Down here, we are solving a quadratic inequality. Solve x squared minus x minus 12 is greater than 0. Okay, so we need to find the spots where this is going to hit that 0. And that one, that appears to be factorable. So first thing I do is think, there's no greatest common monomial factor. It's not a perfect square trinomial because negative 12 is not a perfect square. But I am certain we can find two numbers that multiply to negative 12 and add to negative 1. What are they? Sydney, you got them? Negative 4 and 3. So our solutions are 4 and negative 3. So what those solutions are the x-intercepts. That's where it's going to hit the x-axis. So like it says now, because the original problem was an inequality using greater than, determine the values of x for which the graph of y equals x squared minus x minus 12 lies above the x-axis. Well, so here's the thoughts. It's a quadratic. Quadratics are parabolas. If it has a positive leading coefficient, it's an up-opening parabola. Well, this is an up-opening parabola, and it's going to cross the x-axis at 4 and negative 3. And I don't need anything fancy. I just need to know that's what it's going to look like. And then, since the solutions depended on greater than, I realize, well, that's here and here, because it has to be greater than 0. And again, those are my two arrows going to the extremes, negative forever and positive forever. So my 4 and my negative 3 are my cutoff, but negative infinity, think number line, we roll up to negative 3. We can't include it, because remember it said less than, or greater than, it didn't say greater than or equal to. Or 4 to infinity. So again, interval notation is just like walking along the number line. Now if we wanted to, we certainly could have stopped right here and said, so x is either going to be less than negative 3 or greater than 4, and put that into the inequality first, because that's what we know. I mean, we spent Algebra 2 doing all that. And again, not a real accurate graph, but it didn't need to be. I just needed to show, hey, this is where things are happening, and this is where my solution is going to be. So, quadratic inequalities, the thinking is really a lot similar to what we know about absolute value. So, this one says in the next example, we're going to use the less than or equal to. How will this affect our solution? So I want you to write something down. If it has less than or equal to in it, it's going to be an and or an or. And then, what does that equals bar do for us? How does that change it? All right, with less than, is it going to be an and or an or? I'm going to have an and. And then, Because of that equals bar, we will have to include the endpoints. But the thinking is really, really similar to what we were doing before with absolute value. So this one says, pardon me, solving another quadratic inequality. Oh man, doesn't have a 0 on one side. We know how to do that. Well, then let's move it over. So it's fair game. You know, in algebra we learned one of the properties. We can subtract same amount from both sides and we'll be fine. And now, I think, well, there's not a 2 I can take out of everything. It's not a perfect square or anything, but maybe if I think through it a little bit, and right now I'm just really thinking about equals 0, so let me change this so that those that are watching will know, hey, that's what we're thinking about right now, is where does it equal 0? And I think, well, most of the time in problems involving 20, it's going to have to do with the 5 and the 4. So is there a way for me to use one of those as positive and one of those negative and get a 3 in the middle? And I think, well, what if I did 8 as outside times outside and negative 5x as inside times inside? Yeah, 8x minus 5x, that's the 3x. There it is, right there. So my two solutions, again, you could just set this equal to 0, and very quickly you're going to see that's going to be 5/2 and negative 4. So there are my solutions. Now, if you can get that visual in your noggin, you maybe don't even have to put it into the graphing calculator, because you realize with a positive 2 in front, this is an up-opening parabola, and it's going to cross the x-axis at negative 4 and 5/2. So there's my negative 4, 2.5. Again, it doesn't really matter how far it goes down. That's not what we're interested in. What we're interested in is, when is it equal to the x-axis and below the x-axis? Because this was less than or equal to. And again, you could put it into that interval notation if you really wanted to at this point. We can see it'll look like that. But we have to put this in that interval notation in order to get it at the pre-calculus level. So it's going to be including the negative 4 and the 5/2. Feel like you can do that on your own right now? Okay, so if you see an absolute value, you get the V in your noggin right away. Oh, I see that. I can visually see it without having to graph it. A quadratic opens up, opens down is going to depend on that leading coefficient. You know, is it positive? Opens up. Negative? Opens down. So we don't always have to graph it. And after a while, you maybe don't even need to sketch it. You know, you've got it in your head. In examples 3 and 4, the quadratics were factorable. Whew. What do we do when they're not factorable? Oh, okay. Well, we can try extracting square roots. Again, there's not many of them that are automatically set up for us to do that. In fact, in the section where we had those, they really had to go out of their way to set those up nicely for us. Most of the time, we're going to be completing the square. So that we can show all the algebra behind everything that we're doing. And then, only if the problem asks for it, quadratic formula. But there are times, because we want you to connect the visual with what we're doing algebraically, that we are going to tell you to grab the good old GC. Graphing calculator. So we do want to become fluent in calculator language, so that we're able to find the ones that don't work out quite so nice. Because again, something like completing the square might be a long process and you need to know this answer quickly. So remember, we had what was called an accuracy agreement from section P-5, and that told us we're going to use the graphing calculator. We're always going to use our decimals rounded to 3 decimal places. 3 decimal places. We're getting used to that because that's what they do in calculus. The AP Calc exams tell everybody that you have to have at least 3 decimals, and you can round or you can truncate. Truncating is not a great skill because it's just dropping all the numbers after it, so we use rounding instead. Alrighty, this one says solving a quadratic inequality graphically. So we're being told we're going to use the graphing calculator. Now, if I wasn't told that, then I would have my different methods. You could try factoring and find out it's not factorable. Then you can find out that you'd probably have to complete the square. But we want to see this one visually. So we are going to graph y equals x squared minus 4x plus 1 on our graphing calculator to find where is this hitting the x-axis, because this is already 0 over here. So we'll get that in there. X squared. And I've already forgotten it. Going to the next page. Minus 4x. Yep, minus 4x plus 1. And we'll try zoom 6. Well, there it is. So we just need to know where this and this are at. Well, those two thises are x-intercepts. So again, we're going to call on Blinky, second trace. And this time we're going to go after number 2, the zeros, because that's another name for the intercepts. And Blinky's asking me, am I on the left side of this? Well, yes, you are, Blinky. This little green dot right here, you're to the left, so I'm going to go ahead and hit enter. But now Blinky says, am I on the right side of it? And absolutely not. So I've got to use my right arrow to get below it. Blinky doesn't know above and below. Blinky only knows right and left. Hit enter, enter through guess. And we would write that down to 3 decimal places, so 0.268 is that first x value. And then we'd go after the second one, giving Blinky a workout today. Second trace, number 2. All right, now, here's where some people get goofed up. Now, below it is going to be to the left-hand side of my green dot. So I have to keep track of left and right and above and below. Enter, and then to the right is actually above it, and hit enter, and enter through guess. And Blinky says 3.732. So we're able to find those x-intercepts, but we still have to think about, well, did our problem say less than? Did it say greater than? Did it say less than or equal to? Did it say greater than or equal to? And about where all of that will go. And this one said greater than or equal to. So I'm going to make a little sketch with my 0.2680 and my 3.732. Oops, 3.72. And then, since this was greater than or equal to, I need those. And again, those are my ors. So I have my 2 zeros, just so it's really super clear to those who are maybe watching the video, by using my graphing calculator. And in the blue it says, should we use the solutions above or below the x-axis? Well, if we're talking about greater than or equal to, yeah, we need above. We need it higher. So this is going to be an or situation. If we were to write it the old way, the Algebra 2 way. Oh, and I better put above here for the people that are watching. But we want our final solution in that interval notation. So, how do we start? Write that first interval down, and I'm going to call on somebody. Tell me how we should write that first piece. Lindsay, you're looking done. What'd you put? And a bracket. Now here's where some students will argue, and I think it's a good argument. They would say, but it wasn't perfectly 0.268. It had other decimals behind it. But how else are we going to show somebody that we understand that this had the equals bar? So yeah, we know it's not perfect, but we have to put the bracket there in order to get it. Was that the only piece this one had? Okay. Tristan, you want to finish that up for us? What's the symbol I need to use? Union. Beautiful. There it is. So we can get it there. It's just a few new symbols today. You know, we have the U. We have to keep going with the interval notation and all of that. How are we doing? That's a good place to stop, you know. So tomorrow, you guys won't be here, but I will finish up the notes for P-7. And then we are probably going to take a formative quiz in class, so I'll have that available to you online so that you can take a look at that. And you won't be able to finish this assignment yet until you watch, you know, tomorrow's lesson as well. We only have one assignment for section P7, but there it is. And then I gave you the review, didn't I? Okay, good. I had it on your desk. Yeah, I was worrying myself here that I didn't put that down there. So it'll be review Thursday, review Friday. A students will take the test on Monday. And then, like I said, if you're interested, you know, you can come in Tuesday afternoon around 2 o'clock, take the test. Otherwise, you guys will wait till Thursday. And, you know, we'll have moved on. So we'll have started some of the Chapter 1 material at that point. So totally your call. I'm going to leave it in your hands.